To write the Lewis structure for NaBr, sodium bromide, we first write Na and then Br. Sodium is a metal, and then bromine, that's a nonmetal. So we have a metal and a nonmetal, we have an ionic compound. And in ionic compounds, electrons, valence electrons, are transferred from the metal to the nonmetal. So on the periodic table, sodium is in group 1, so it has 1 valence electron. And then bromine's in group 17, sometimes called 7a, and it has 7 valence electrons. When sodium and bromine bond to form sodium bromide, the sodium loses a valence electron to the bromine. It transfers this valence electron. Because of that, it's lost an electron. Electrons are negative, so the sodium has a positive charge. The bromine gained the electron. Again, electrons are negative, so now the bromine has a negative charge. And the positive sodium ion and the negative bromide ion, they come together, they're attracted, and form an ionic bond. To show that they're attracted, that electrostatic attraction is what's forming the bond and not them sharing electrons like in a covalent bond, we'll put brackets around the negative ion. Often you'll also see brackets around the positive ion. And that makes this the Lewis structure for NaBr, sodium bromide. This structure is what we call a formula unit. Ionic compounds are crystals, and they're made up of a bunch of these formula units in a repeating pattern. But this is very useful to show us how the electrons have been transferred from the Na to the Br in this sodium bromide. This is Dr. B with the Lewis structure for NaBr, and thanks for watching.